Hello and welcome to the session on alligation. Hi, I am Ravi Handa and my Twitter handle is @Ravi Handa, which you can use to provide feedback. In today's session, we'll discuss how to solve mixture problems using the concept of alligation. Well, what is the fundamental idea behind alligation? That is, the ratio of the weights of two items mixed, let's say you are mixing x1 and x2, will be inversely proportional to the deviation of the attributes from these two items from the average attribute of the resultant mixture. A little confused? Well, anyone would be. You should remember this formula: quantity of first term minus divided by the quantity of second term, or the ratio is the value of the second term minus the average you want to attain, and the average minus the first term. You can use this handy diagram to get the value. Let's say the first term is x1 and the second item is x2. You want the average to come out as x. Then the ratio of the quantities will be x2 minus x. From this you subtract the value of x and x minus x1, because x will be the middle value of the lot. I can understand if this becomes a little confusing, and that is why I have taken a couple of examples. Let us look at the first one. In what ratio should you mix the two varieties of milk costing 30 rupees per kg and 40 rupees per kg to get the resultant milk? This should be resultant milk of 33 rupees per kg. Use the concept of alligation. You need 30 and 40 rupees per kg is what is given to you. You need to get 33 as a result. So what should be the ratio in which you should mix them? Well, how much is 40 minus 33? 40 minus 33 is 7. And how much is 33 minus 30? 33 minus 30 is 3. So you can simply say that the two quantities of milk should be mixed in the ratio of 7:3. That's it. Nothing else is required. You can just simply apply the alligation. Higher value minus the value you want to achieve, and the value you want to achieve minus the lower value. Let us look at a slightly more complex problem on the same idea. Let's say there are two containers A and B of milk solution. The ratio of milk and water in container A is 3:1 and in container B it is 4:1. How many liters of container B solution has to be added to 20 liters of container A solution such that in the resulting solution the ratio of milk to water is 19:6? Well, that is the problem. Essentially, if you want to break it down to, container A has milk and water in the ratio of 3:1, B has it in the ratio of 4:1. You want to mix them and get the ratio of 19:6. You have 20 liters of container A and you have to find out the quantity of container B required. For this, the first thing that you will need to do is figure out you are applying alligation on what quantity. You can apply alligation either on milk or on water. Let's say I apply the alligation on milk. So, what is the fraction of milk in the first quantity, in the first container? In A, fraction of milk in container A is 3/4. Fraction of milk in B is how much? In B, the ratio is 4:1. So it is 4/5. So what is happening is that we are mixing 3/4 with another container that has milk in the ratio of 4/5. And what do I want as the result? I want the result as 19:6, or fraction of the milk in result is how much? It is not 19:6, it is 19/19 plus 6, or 25. So I get 19/25 here. Now, to get the value or the ratio of the quantities, what do I need to do? The first quantity will be 4/5 minus 19/25. How much does this come out as? 4/5 minus 19/25? Well, this becomes 20 by 25 minus 19 by 25, which you can say comes out as 1 by 25. Let me just remove this. 4 by 5 minus 19 by 25 comes out as 1 by 25. And what do I have for the second part? I have 19 by 25 minus 3 by 4. How much does this come out as? Well, the LCM in this case is 100. 19 into 4 is 76. 25 into 3 is 75. 76 minus 75 by 100, and that comes out as 1 by 100. So I've got my values as 1 by 25 and 1 by 100, which means the ratio of the two quantities should be 1 by 25 is to 1 by 100. It is very difficult to solve these kind of questions when the ratios are in fractions. So to solve this or make it simpler, I multiply the entire ratio by 100. So what do I get? I get the ratio as 4:1. And now I am given that 20 liters of container A is what I had. So if it is 4:1 and I have 20 liters in container A, how much will I have in container B? Well, it has to maintain the ratio of 4:1. So I will have 5 liters in container B. And that is the value that we were looking for. With this, I'd like to wrap up this session on alligations. If you have any feedback, please reach out to me via Twitter at my Twitter handle, or you can also email me on my mail ID, which is ravihanda@gmail.com. Thank you guys. Thanks a lot.